Hi guys, it's Miss Alstrom. So let's look at properties of absolute values. One of the most important things, in order for all of these properties kind of make sense, what you have to understand is that absolute value, and you probably already know this, is the distance away from zero. Okay, so when you look at number one, you can say the distance away from A has to be greater than or equal to zero. So that's the way I read these, and it makes perfect sense. Distance has to be greater than. It could equal zero, right? Distance has to be greater than or equal to zero. And that's a property that makes perfect sense to me. The second one, you can say that the distance away from A, it doesn't matter if it has a negative because it's just going towards the negative side, but the distance is going to be the same for A and A. The distance for A from 0 to positive A is going to be the same. Once again, all of these make perfect sense when you read it from distance away from 0. Okay, so distance away from, distance of A equals 0. So therefore, it implies that A equals 0. That makes perfect sense. Okay, A minus B, the distance of that equals 0. So therefore, A equals B. Because when you subtract one distance from another and you end up in the same place, then they equal each other. Right? I think that's how it works. Well, look at this funkiness right here. Okay, so absolute value of A times absolute value of A times B equals absolute value of A and then absolute value of B applied out. And that makes sense because the sign does not get affected whether you take the absolute value first or you take the absolute value at the end for multiplication. And that goes the same for here. When you take, you can think of them as divisions. The entire absolute value, when I take the entire absolute value, it doesn't matter when I take the absolute value for division and multiplication. I mean, division is the same thing as multiplication. So it doesn't matter when you take the absolute value. Now, these are interesting. If you take a look, the absolute value of A plus B has to be less than the absolute value of A plus the absolute value of B. And if you really think about it, if you add up two numbers, two integers, and you can even put negative numbers in here, like -3 plus 5, the absolute value of that is going to be 2. And that's going to be less than or equal to, when you take the absolute values of individual numbers, of integers, and then you add them together, you're always going to have a positive, or maybe a 0. But I mean, it's going to be bigger than when you take them and add them first, including their negative integers, and then take the absolute value. Does that make sense? I hope so. Okay, let's take a look at these. So the same goes for here too. If I subtract the 2, it's going to be greater than or equal to when I take the absolute value of it individually, because when you take the absolute value, it gets rid of the sign. And so if it gets rid of this sign, and then it gets rid of that sign, and then you subtract, which would be -2 and -8. Absolute value of -8. So just think about the fact that when you add or subtract two numbers together, you're going further into the negative or further into the positive, and then you take an absolute value of that, that's going to be a greater distance than when you individually take their distances. Take their distances and then subtract them from each other. If you go take it to the -3 and then take it to the -5 again, that's going to be a much bigger distance than when you take the absolute values and then subtract them. Okay, and then this mess right here that you see just basically says that if you have an absolute value, the distance away from zero has to be less than or equal to b, okay, of a. The distance of a has to be less than or equal to. So the distances, like let's say a was here, okay, and then b is here, and then -b is here. Okay, that means that if it's less than or equal to, then it's going to be all of this distance right here in the middle. Because if it's smaller than that distance, then it's going to be all kind of like crammed in. Okay, but over here, it's greater than, so it's going to be the ors. It's going to be the two b and the -b. So it's going to be these out here. Whoops. I haven't made a video in a long time. So there we go. That doesn't make any sense. Let's take that off. So this is what A is going to be. This entire distance that's less than or equal to. And this is going to be greater than or equal to. Okay? Okay, good job. So, sorry, I didn't have nice little slides made. I was kind of, you know. So, this is from your textbook about basically the absolute value of any kind of function is a linear function. There's two linear functions, and one of them has a positive slope and another that has a negative slope. And this would be the f of x equals x, and then this will be the f of x equals -x. And we teach to kids to kind of make linear functions a little bit more difficult. And so if you take a look, the domain and range of linear functions, f of x equals x or f of x equals -x, for domain, it's going to be x, and x is all real numbers, and range also. Y is an element of all real numbers. But if you see here, for absolute value equations, there's kind of a vertex. Okay, there is a vertex, and it stops at that vertex. And so this is the parent function. So you know that 1, 1, -1, 1, and 2, 2, -2, 2. There's always 2 points, 2 corresponding points, because if you put in an input of a negative or a positive, it's going to give you an output that's a positive every single time. And this is also the minimum point. And so what do they have in common? You can say that they're similar. You can say that they're similar in the way that it looks, as long as the domains are still going to be the same, but the range, it's going to have that lowest point as the restriction. So the range of this is going to be y such that y has to be greater than or equal to 0. Okay, good job. Okay, so let's go ahead and solve this. I did it and then I messed up, so I kind of went back. Okay, determine the domain and range of y equals -2, absolute value of x minus 4 plus 1, and confirm graphically. So we are going to go over transformations.
vertical and horizontal stretches and compressions. But before we do that, we don't have to really worry about this multiplier of 2, but we know that this is a reflection over the x-axis. And this is up 1. And so the domain of all absolute value functions, these are absolute values, right? X such that X is an element of all real numbers. And then the range, now we've reflected it over the x-axis and went up 1, y such that y has to be less than or equal to 0. Whoops. See what happens. If I graph it, first I'm going to go ahead and figure out my vertex. So negative 4 and 4 and 1. 1, 2, 3, 4, 1. Now that's going to be my maximum point right there. And then I'll kind of treat this like slope. Because these are linear functions, right? So you can go like negative 2 over 1. You can go down 2, right 1, down 2, left 1. Yeah. I mean, that's all they are. Those vertical stretches and compressions and those kind of things, it's just slope. It's just hard because there's like words associated with it. Okay, example 14. Determine the domain and range. Oh, we've got some business going on in there, and sketch the function. If you notice that there's some business going on in there, I cannot figure this one out. Whoa. Until I take that b value out. This is like the b value right there. Okay, so let's go ahead and take the b value out. So I'm going to rewrite this as negative 2x plus 2 plus 1. And then I'm going to rewrite it as, factor out the negative 2, x minus 1. Plus 1, and then look what I can do. I can take this, because that's a property, right? I can take both of the multiplications. It doesn't matter if I take it together or separated. So I can go back here, negative 2 absolute value, and then x minus 1 absolute value plus 1, and then, well, what do you know? Implies y equals before. Okay, and then implies that y equals absolute value 2, x minus 1. Gosh, my voice. Okay, and now, before it kind of looked like, hey, it might be a reflection over the y-axis. It kind of is, but it's also, you know, it's not reflected at all, because if you reflect over the y-axis, it is what it is. It's the same thing, because it's an absolute value function, just like a parabola. Reflecting it over the y-axis really doesn't do much, but then you move it right or left. But anyways, okay, so the domain of this, don't you love it when the domains are always going to be the same? X is an element of all real numbers, and then y, or the range, I'm sorry, y such that, and it went up 1, so y is going to be greater than or equal to 1, because it went up 1. And I can draw it, and the vertex is going to be positive 1 and positive 1. positive 1 and positive 1 right here. And the slope is going to be 2 over 1. So up 2. 1, 1, 2 to the right 1. The right 1. There we go. I hope I did that right. Oh. Did I go down 2? Down 1, 2. Yes, I did. Good job, Miss Alstrom. Okay, example 15. Okay, I'm going back to this. There you go, and sketch the function. There we go. Okay, good job. Example 15. Now we get to solve them. Do you remember how to solve absolute value equations? Of course you do. First, you have to isolate the absolute value. So I'm going to subtract 2, and then I get a negative 2, absolute value of 3 plus 6 equals negative 12. Divide both sides by negative 2. 3x plus 6 equals 6, right? Whoops. Okay, and then after you isolate the absolute value, you can either, to break apart that absolute value sign, you can either split it up as implies 3x plus 6 equals plus or minus 6, or you can split it up as negative 3x plus 6 plus or minus equals 6. It doesn't matter. You're going to get two same answers. Okay. So when I split this up and when I solve, I get 3x plus 6 equals 6, and 3x plus 6 equals negative 6, and x equals 0, and x equals negative 12, and then negative 4. Okay. And then we check to make sure we put it back in. And one of the things that the book tells us, I think the book is trying to tell you, which I tell students all the time, that equations are actually systems of equations, always. I used to say that all the time when I taught algebra 2. So if you see something like absolute value of 3x plus 6 equals 6, that's y equals, that's one of your systems, and this is the other system. And you're just looking for their intersection points. I mean, if you think of it like that, all equations is just systems of equations every single time. Okay? So for this one, I mean, if you take a look, then you could say, hey, we have y equals this, then we have y equals that. And you're just looking for intersection points. And so let's go ahead and take a look at this. Wait a second. Did I skip one? Did I skip one? No? So once again, we're going to get, you can either do, this implies that it's plus or minus x plus 1 equals negative 2x minus 5, or x plus 1 equals plus or minus negative 2x minus 5. Up to you. Whatever. Okay. X plus 1 equals negative 2x minus 5. And then for that one, you're going to get positive 2. 3x equals negative 6. X equals negative. Is that negative 2? Yeah, I think so. Okay, good job. And then you're going to get negative x minus 1, because you have to distribute this negative through. And you have 2x minus 5. And then that's positive 2x, positive x equals positive negative 4. Ew. Now, we have to see if both of them work. Okay? Because sometimes they don't work. Okay? I mean, for this one, when the systems of equation involves an absolute value and a horizontal line, you kind of have two solutions, unless it's a vertex. Okay, but you're going to have two solutions, just like parabolas. But this one, I mean, it's a line. This is a line, right? This is a linear function. And that one right there is an absolute value function. So there might be, like, depending on the slope of the linear function, it might not capture both. So you have to check. And it doesn't take that much to check. Negative 2, negative 2. Is that right? Yeah. Minus 5. Is it negative 1 equals negative 4 minus 5? That kind of doesn't work, right? So x equals negative 2 is not going to work, right? Let's try x equals negative 4. Negative 4 plus 1 equals negative 2 times negative 4 minus 5. We have negative 3 equals 8 minus 5. I have a feeling that the left-hand side is going to equal the right-hand side. Yay, yay, yay. So that is the only solution. Okay, got it? Good job. Let me stop the video so I blow my nose. Okay, back to work. Now, we have two absolute value functions, and we're trying to see where, okay, they intersect. Okay, and we could have done it for the last one too. We could have graphed both of them. Let me go ahead and get out my graph. I mean, I could have gone in here and I could have done y equals negative 2x minus 5, enter, and then let's go into math, absolute value of x plus 1, and then we can graph them. There you go. And then we could go into trace table set. I forgot how to find the, I'm pretty sure you guys know. And calculate, probably. Calculate, intersect. Enter, 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 enter. Sure. I don't think I'm doing this right. Well, yeah, I did. Negative 3. Right there. Okay. Wow. How this stays with you. Okay, so solve absolute value of 3x minus 4 equals 2x plus 3, and check your answers both numerically and graphically. Okay, so to solve this, okay, we need the positives and we need the negative, but we have to choose one side to either have the positive or negative. So you can have plus or minus 3x minus 4 equals, and we can take this side off, or we can do 3x minus 4 equals plus or minus 2x plus 3. Or you can even square it. And because squaring something, okay, you're only going to get positives, so you can actually square it. And you can actually square this like this. Square it.
How am I going to do it? Not this way. I'm going to do it this way. So we have 3x minus 4 equals 2x plus 3. And this is going to give me implies minus x equals 7. 7. Sorry. I shouldn't say 7 that harshly. 3x plus 4 equals 2x plus 3. I distributed that negative through. And so that's going to be a negative 5x. Negative 5x equals, what is that? Negative 1. That implies that x equals 1 over 5. Now let's check. Okay, let's check x equals 7. So x equals 7. Okay, they do a little fancy way of doing the left-hand side and the right-hand side and making sure that they equal each other. But you know, we could do that if we wanted to. Left-hand side, I mean, you know, whatever, times 7 minus 4. And then right-hand side, 2 times 7 plus 3. That's going to be 21. 21 minus 4. What's 20? What's 21 minus 4? 21 minus 4 is 17. And then right-hand side, 14, 17. Yes, yes, yes. So x equals 7 works. How about x equals 1/5? I don't think that's going to work because I just think maybe, okay, maybe. I just don't want it to because it's a fraction. Okay, so let's look at left-hand side. So absolute value of 3 times 1, 5 minus 4. Right-hand side. And 2 times 1/5 plus 3. That's going to be 3/5 minus 4/5. No, not 4/5. So 20/5, right? So that's going to be absolute value of negative 17 over 5, which is going to be, goes in absolute 17 over 5, so goes in 5 times. Nope, goes in 3 times. 35, and then 2. Do my multiplication in Korean. Okay, and then let's take a look over here. 2/5. I think it's gonna work. And then 15 over 3. Over 5. Did I tell you that I'm horrible at multiplication? Okay, and then 17. Oh, look, we could have just gotten it from here. And then that's 3 over 2. 3 and 2/5. Mixed numbers. Fun, fun. Okay, so both of them work. And if I graph this, if I graph it, I'm going to use my graphing calculator because, you know, it's always cool to put your graphing calculator in a video. 1 absolute value, 3x minus 4. Math. 1 absolute value, 2x plus 3. Sorry. Let's go ahead and make the windows negative 20 because we need to get that 1 enter the x equals 7. Be kind of out there. So I just want to make sure and then graph it. So it looks like we have 2. And if I wanted to find out, so I can calculate and then find the intersection. And enter, sure. 0.2
y is 3.4. Okay, x equals 0.2, so that was 1/5. And then I could go into second calculate again, go and find that, kind of get closer to the other one right here, press enter, 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 7, x equals 7. There you go. You're looking for, once again, intercepts. Got it? Or points of, yeah, where they intersect. Okay. That's what it is for, that's all it is for absolute value equations. Next video is on absolute value inequalities. Fun. Bye.